Out there, in the silent dark of space, a golden eye drifts, a human creation, the James Webb Space Telescope. It floats 1,000,000 miles from Earth, shielded from the sun, peering into the ancient cosmos. JWST sees in infrared, revealing the hidden heat of stars and the faint glow of the first galaxies. It's a time machine, a truth seeker, and the pinnacle of our ambition. For months it's shown us stellar nurseries and the atmospheres of distant worlds. But its greatest purpose to help answer the oldest question, are we alone? The JWST was built to see what has never been seen before. Imagine its honeycomb mirror collecting photons that have traveled for millennia, each a messenger from a distant time and place. The telescope deciphers reality, one wavelength at a time. Recently it turned its golden eye toward our nearest stellar neighbor, Proxima Centauri. A small, dim red dwarf just over 4 light-years away, practically on our cosmic doorstep. Orbiting it, Proxima Centauri b, a planet slightly more massive than Earth with a year lasting only 11 days. We've long wondered about this world. Could it harbor life? The JWST was about to give us a clue that would ignite the imagination of our entire planet. This was not just another observation. It was the beginning of a new chapter in our search for life. The universe was about to reveal something extraordinary, and humanity was ready to listen. The data streamed back to Earth, a torrent of numbers from JWST's instruments. At first it looked routine, a rocky planet passing in front of its star, but then, on Proxima b's night side, where darkness should reign, there was a glow. Not a flicker, not a flash, but a steady, structured light. Scientists stared in disbelief at the heat map. The day side was warm as expected, but the night side glowed in a concentrated region. It looked organized, like Earth's cities seen from space. A web of interconnected points of light. The implications were staggering. A steady, artificial-looking light on the night side of an alien world. This wasn't a signal beamed at us, but a passive sign of existence, a techno-signature. The excitement was electric, but caution prevailed. Extraordinary claims require extraordinary evidence. The team triple-checked everything. Could it be a glitch, a misinterpretation, or a strange natural phenomenon? Before whispering aliens, every other possibility had to be exhausted. The universe is full of wonders, and nature is often more imaginative than we are. The search for the truth had just begun. The world watched as scientists probed the mystery. Was this the first sign of another civilization, or just another cosmic trick? The answer would change everything. For now, the glow remained, a silent beacon from a distant world, and humanity waited. The first step, hunt for ghosts in the machine. Could a stray reflection or sensor noise have created a false positive? Engineers ran countless simulations. The glow remained, tied to the planet's surface, rotating with it. The signal was real, coming from Proxima b next, the star itself. Could a flare cause the glow? Red dwarfs are tempestuous, but the data showed no flare activity during the glow. The glow was steady, not brief like a flare. What about the planet? Could volcanism explain it? The thermal profile didn't match molten rock or silicate vapor. The light was too cool, its spectrum all wrong, and the pattern too structured for chaotic geology. Nature tends to be messy, this was not. After weeks of analysis, every known error and natural phenomenon was ruled out. Other telescopes turned to Proxima b. The glow persisted, the evidence mounted, no natural explanation fit. The possibility of an artificial origin, a techno-signature, remained. The scientific paper was cautious, but its message was clear. We may have found something. The world took notice. The search for answers intensified. What is a techno-signature? It's evidence not just of life but of technology, an intelligent civilization altering its environment in detectable ways. For decades, SETI focused on radio signals waiting for a deliberate message. But what if nobody is calling? Techno-signatures are broader, like seeing lights in a window, even if no one answers the phone. The glow on Proxima b is a potential passive techno-signature. If artificial, it wasn't meant for us. It's just light, perhaps for illumination or industry. Other techno-signatures could be industrial pollutants, heat from massive structures, or non-natural shapes in orbit. JWST's ability to analyze atmospheres and detect faint heat has opened a new field. We're no longer just listening, we're looking. This discovery shifts our search paradigm. We might find evidence of neighbors simply by observing their lives. The Proxima glow has given us a new way to look at the stars. From space, Earth at night is a marble speckled with webs of light, our techno-signature. It tells the story of our civilization, visible to any distant observer. Now compare that to Proxima b, a concentrated, stable glow on the night side. The energy output is immense, far beyond natural bioluminescence. The spectrum is peculiar, not matching the star or rock, suggesting an artificial origin. Proxima b isn't Earth, it's tidally locked, with one side in perpetual darkness. The lights might not be cities. They could be agricultural centers or data hubs. Our comparisons may be inadequate, but the parallel is powerful. The search for extraterrestrial intelligence is a search for ourselves. Seeing a pattern that mirrors our own handiwork is profoundly moving. It connects us across light years. For the first time, we may be seeing physical evidence of another civilization. The universe suddenly feels smaller and more connected. Science demands skepticism. Could the glow be natural, exotic geology, or atmospheric chemistry unique to red dwarf planets? Massive bioluminescence is possible, but the energy required would be colossal. Exotic minerals could re-emit energy, but the pattern is too organized. The structure, stability, and spectral signature don't fit any known natural model. Occam's razor suggests the simplest explanation. In this case, city lights may be less far-fetched than inventing new physics. In 1950, Enrico Fermi asked, "Where is everybody?" The Fermi paradox highlights the contradiction between the high probability of life and the lack of evidence. We've listened for radio signals, scanned for megastructures, and found only silence. Maybe intelligent life is rare, self-destructive, or hiding. The Proxima glow offers a new answer. Perhaps we've been looking for the wrong thing. Instead of loud messages, we should seek quiet, passive signs of existence. Maybe the galaxy isn't silent, just subtle. JWST can see the faint heat of industry, the glow of cities. If the Proxima glow is a techno-signature, it reframes the Fermi paradox. Everybody isn't missing, they're just next door. The Great Silence may be a failure of perception, not absence. With JWST, we're finally beginning to see. The universe may be full of neighbors, quietly living their lives. And now, we're listening in a new way. We stand at a pivotal moment. The light from Proxima b has traveled years to reach us, but it's also crossed the expanse of human curiosity. From ancient stargazers to modern scientists, we've always been explorers. This faint glow is a new coastline in the cosmic mist. It means the universe may be far less lonely than we imagined. Knowing we might share the galaxy could change our perspective and unite us. Our journey is far from over. We must keep observing, build better telescopes, and seek understanding. This is not an end, but a beginning, an invitation to explore and imagine. The universe is a stage for life, and perhaps intelligence. Look up among the stars, is a world that may glow with civilization. We don't know who they are, but the possibility changes everything. The adventure is just beginning.